Let's talk about uniform circular motion. So what is uniform about the uniform circular motion? Actually, before that, I would like to answer this question. What is a circular motion? So any circular path, which is basically a circle, it can be a track or it can be anything. It can be a toy train track or a race course track, if not a park or whatever it might be. It has to be circular. So this is the circular path. And if we have an object moving around this on this path from one end to the other end in one particular direction, it is said to be a circular motion. Now, what is uniform about a uniform circular motion? Say we have a start point, this point, and at this point, say we see a particular a car. So we see that car at 3 o'clock and again at 3:20. It's moving. It's not stationary, it's moving in one particular direction. So at 3 o'clock we saw this car, and 3:20 again we saw, 3:40 again we saw, 4 o'clock we saw, 4:20 we saw, 4:40 we have seen that, so on and so forth. So if we happen to see during this time, it is said to be uniform. Now the question is why? What's so special about this set of timing? Yes, they are at equal intervals. So every 20 minutes we are looking at this particular vehicle. It need not be 20, it can be 20 seconds also. It can be 10, 15, 17.4, whatever it might be. Whatever comes to your mind. But the thing is, it has to come back to that point in the other direction. Walking or passing through or not passing through or traveling through this circular path. This is and so the word uniform. It is covering equal distance in equal interval of time on a circular path. As simple as that. It's basically uniform motion on a circular track. I hope you guys remember the definition of uniform motion. Now, when an object moves in a circular path with uniform speed, such a motion is called as uniform circular motion. That's it. So it's basically an extension of uniform motion. And now you add the word circular because the object or the person or whatever it might be, they are moving along a circular path in a particular direction. So the question is the velocity uniform or no? So yes or no. Over here is the velocity uniform. We are talking about speed being uniform over here. Is the velocity uniform or not? Please pause and think over. The answer is no. Next question is why? Why is it not uniform? The speed is uniform, right? Velocity is a vector quantity, is it not? And what does it have? It has two things. Velocity has two things. One is rate of motion and the other one is, yes, direction. So here the rate of motion is constant. That's why the word uniform, is it not? While the direction is not fixed, it's changing every moment of time. So this is changing, and so the answer is no. Here the velocity is not uniform while the speed is uniform. Okay, speed is fixed while the velocity is not fixed. It's changing every point of time. So one last question. So what is the direction of the object moving in a uniform circular motion? So for that, I'll take the help of this particular picture and well, the answer is tangential. What is tangential? See, it's something like this. You take any point, right? And you draw a tangent. This is a tangent. Okay, at this point, for this point, this is a tangent. And say this particular object is moving in a circular path, right? Clockwise. So at this point, say point A, if we happen to look at the direction of the object, it would be in this particular direction. It would be tangential. Tangent is a line which touches the circle at a single point. Okay, it touches a circle at a single point. And the direction would be along the direction of the, in the direction of the, whatever the movement is. So basically every moment of time, like you can draw there are infinite possible tangents, right? So at this point it is, so let me actually do this. So the tangent at point B is this, and you can take any, any line. It's this is another tangent at point D. This is a tangent. So you can draw tangents at pretty much all the points, not pretty much, all the points by default. You can draw tangents. So that would be the direction at that moment of time, at that particular point. Okay. So what is the direction? So that will be tangential. So there is a small practical to understand this. There are actually one or two. So I'll be adding that. This is your answer. That's an extra information for you guys to kind of understand, and it makes it a bit interesting. If not, that this particular information is not required. Anyways, you guys learn everything. It's not too complicated. Okay. Again, uniform circular motion is nothing but an uniform motion. That is, we are covering equal distance in equal interval of time. The thing is, it is being done on a circular path in a particular direction, either clockwise, if not anti-clockwise. So as a whole, it is a uniform circular motion. So is the velocity fixed over here? No. It is only the speed that is fixed, not the direction. Direction can't be fixed. But what is the direction then? Well, it depends on what point we are talking about. Any point, if you want to find the direction, consider that point, try to draw tangent. And whatever the tangent direction and pointing towards, or whatever it is, right? Basically, whatever the direction is, tangential direction, and along the path of the motion, right? The object would move along that path basically at that moment of time. So basically draw a tangent, and that is your direction at that point. That's it. As simple as that. And now you guys have to pause and copy this.